A question for the 70s. Can man survive? Here's one answer from the president of the Center for the Study of Democratic Institutions, Pulitzer Prize winner Harry Ashmore.
That may be an act of unfounded optimism, or perhaps even an act of faith. I think man can survive. I'm not sure that I'm not saying that because I can't face the alternative. But more seriously, I do think that man has always been able to survive those deprivations. There isn't a question that we're in some kind of a technological scientific revolutionary period. I think it has to be recognized that the rate of change has become the qualitative factor now in the life of man, as well as change itself, as well as the qualitative changes that are taking place all around us, the speed with which these changes take place, the inability of us as individuals to keep abreast of the change, to adapt to the change, to adjust to it. And this, in an institutional sense, is what I think is happening to government everywhere in the world. And it seems to be, interestingly enough, the capitalistic electorum of the Western-style capitalistic democracy that we have in the United States seems to be doing no better than the socialist countries in the communist bloc. Or at least put it the other way around. Those tightly organized, hierarchical, dictatorial societies seem to be no better able to meet this technological, scientific, rapidly changing environment than does the free societies. Although we have led the world in perfecting the technological devices, we seem to be doing no better than the others in bringing them under some kind of control. So I think it is a crisis situation, but I don't think that it means that we will not be able to adapt ourselves by conscious will to find the means to survive.
Nothing on either side of the Iron Curtain has hastened the rate of change in man's life as much as the subject of this report, the atom and man. Produced by Walter McGraw for Group W, Westinghouse Broadcasting Company, with Dr. Harry Shapiro of the Social Services History as consultant. I'm Garry Moore. Ecology is today a rather new household word. Yet almost a decade ago, the late Aldous Huxley was already worrying about and lecturing about that subject. Here's a part of what he said at the Center for the Study of Democratic Institutions.
Thanks to our rapidly advancing science and technology, we have very little time at our disposal. The river of change flows ever faster, and somewhere downstream, perhaps only a few years ahead, we shall come to the rapids, shall hear louder and ever louder the roaring of a cataract. Modern war is a product of advancing science and technology. Conversely, advancing science and technology are products of modern war. Nuclear fusion and nuclear fission have revolutionized war. But it was in order to wage war more effectively, firstly USSR financed the crash program that resulted so quickly in the harnessing of atomic forces, primarily for military purposes, and secondarily as a byproduct of labor, as a source of industrial power. Both in the USA and the USSR, research in pure and applied science is lavishly financed by military planners whose first concern is the development of better and better weapons in the shortest possible time. In the frantic effort on one side of the Iron Curtain to keep up with the Joneses, on the other side to keep up with the Ivanovs, these military planners spend gigantic sums on research and development. The military revolution advances under forced draft, and as it goes forward, it initiates an uninterrupted succession of industrial, social, and political revolutions. It is against this background of chronic upheaval that the members of a species biologically and historically adapted to a slowly changing environment must now live out their bewildered lives. The crash program, which produced the A-bomb and ushered in a new historical era, was planned and directed by some 4,000 theoreticians, experimenters, and engineers. To parody the words of Winston Churchill, never have so many been so completely at the mercy of so few.
We've been told that man's ancestors had tools, crude though they were, some million years ago. It took him until only 10,000 years ago to learn to farm. Then it took only a couple of hundred years ago to develop the Industrial Revolution. Now, in the lifetimes of many of us, who were once solemnly taught that the atom could never be split, we've seen the suggestion made that E equals mc squared. We've heard of Hiroshima and Nagasaki and have been solemnly assured that the atom has been harnessed. A bit much for one lifetime. And with the horror and hope of the atom has come disappointment. Sheldon Novick is the editor of the magazine Environment.
I think by now we can see that the expectations people had for our peaceful have not brought to the board. The feeling of euphoria that there was in the 40s and even through the 1950s, that the peaceful atom would somehow transform national life and perhaps the whole character of the world and bring a whole cornucopia of benefits. This clearly has not happened. The one large advance that's been made is the development of commercial nuclear electric power plants, and these are only about as expensive as the coal-burning plants. They're not any cheaper, and they certainly haven't transformed our life in any way.
No, but they have engendered controversy. Much of this concerns the standards on allowable radiation exposure as they are regulated by the Atomic Energy Commission. First, what do we mean by radiation? Dr. Dean Abramson is the vice chairman of the Scientists Institute for Public Information.
What we're talking about is any exposure to so-called ionizing radiation. We're talking about X-rays, whether they're used medically, whether they're used in other contexts. We're talking about cosmic rays. We're talking about exposures to radioactive materials, whether they're naturally occurring in the Earth's crust or whether they're man-made, that is the result of the atomic age, the atomic technology. We also have to talk about emissions from various electronic devices and so forth, but those are smaller than these other sources. But that's what we're talking about. As far as standards go, there is essentially no standard affecting medical exposures. This is left up largely to the discretion of each individual practitioner. The situation may or may not exist for long. There's talk that this has to be regulated in some way, especially as non-medical exposures increase. Non-medical exposures from things like weapons testing are discussed a great deal, but there's nothing even comparable to standards. The standard is supposed to be no weapons testing and therefore no exposures, but this isn't realizable as long as China and France and so forth test. The controversy that's been in progress for several years in this country and getting much more intense deals with exposures from so-called peaceful uses of the atom.
Why are we worried about these? Dr. Victor Bond is the Associate Director in charge of Life Sciences at the Brookhaven National Laboratory.
Ionizing radiation has the characteristic of being able to penetrate into tissues to produce ionization, which in turn produces biological effects. At high doses, this is doses of the order of 100 or more, so-called RAD, it can cause early effects such as illness, changes in particular organs. In addition to so-called early effects at high doses, it is known to produce late effects such as leukemia, cancer, and genetic effects in addition.
This is well known in high doses. The question, of course, becomes important when it comes to very low doses. We have an enormous store of experimental evidence, experimental data on effects of radiation on animals and on man. A large number of scientists work in this area, continuously review these data. The standards are actually set by groups of individuals knowledgeable in radiation effects, or international groups such as the International Commission on Radiological Protection, our national groups such as the National Commission on Radiation Protection, the Federal Radiation Council, groups that review these very considerable and extensive bodies of data, and on the basis of these data come up with recommendations for exposure that, in their view, will produce no significant increase in the overall harm to the population.
But are those standards stringent enough? Two research scientists at the Atomic Energy Commission's Lawrence Radiation Laboratory said they were not. Dr. John Goffman was one of these. Producer Walter McGraw talked to the other, Dr. Arthur Tamplin.
By law in the United States today, the public is allowed to be exposed to a certain amount of radiation. We looked at the data which has been accumulating for the past 20 years on the biological effects of radiation. We concluded that if the population of the United States were exposed at this allowable level of radiation, that each year in the United States there would be some 32,000 additional cancer deaths. This was a 10% increase in the present cancer rate in the United States. One of the reasons why these conclusions had not been reached earlier is that a significant amount of data was generated in the past several years since the present standards were established by the International Commission on Radiological Protection. The reason why additional data became available is that when an individual is irradiated, his cancer doesn't develop within a few minutes after the irradiation. It takes a period from 5 to 20 years for the cancer to become manifest. So that over the past several years since the standards were set, a number of cancers began to appear in radiated populations in organs where cancers hadn't appeared previously. So that the solid information on the production of cancers really wasn't available until just recently. In addition to that, the more recent data that's become available from countries where socialized medicine is practiced, and these countries are able to keep better medical records on families, so that they're able to trace families through 2 to 3 to 4 generations at the present time. The information that's becoming available from these countries indicates essentially all forms of human disease have a genetic component. So the data now that's becoming available demonstrates that the major diseases of the United States, such as heart disease with its attendant heart attacks, diabetes, rheumatoid arthritis, and the major mental disease in the country, schizophrenia, all have a genetic component to them. So that any increase in radiation, which would result in an increase in the mutation frequency in the population, would result in a proportionate increase in these major diseases, and essentially all human disease. The data indicated that there would be between 150,000 and 1,500,000 additional deaths each year as a result of the genetic consequences of being exposed at the present allowable radiation limits. In the United States today, the average exposure for background radiation is about 0.12 rads. Now, rad is simply a measure of the amount of radiation, much the same way as the watt is a measure of the amount of radiation that a light bulb puts out. In addition to that, the average exposure to people in the United States from medical radiation was in the vicinity of 50 millirads per year. In the United States today, the combination of background and medical exposure is about 170 milligrams per year. The only logic that was used in setting the present guidelines is that they were set at 170 milligrams per year. In other words, the allowable exposure simply doubles what we were getting today. There was no other significant amount of logic associated with setting the present standard. Just because we have been exposed to radiation from background and from medical practice doesn't mean that this radiation is harmless. It's estimated by geneticists that the combination is producing somewhere in the neighborhood of 10% of the genetic harm that we see in the population today. 10% in terms of cancer today would be 32,000 additional cancer cases each year. In terms of schizophrenia and rheumatoid arthritis and diabetes, it would undoubtedly mean somewhere in the neighborhood of 100,000 additional cases. Dr. Joshua Lederberg, Nobel laureate in genetics at Stanford, has estimated the effect of the guideline radiation in a different way than Dr. Goffman and I have. He has estimated the cost to the public. His estimate is that it would cost an additional $10 billion a year in medical expenses if the population of the United States were exposed to the guidelines.
There's been a good deal of criticism on your findings. One of the arguments was that your calculations were linear and therefore were invalid. What is meant by that?
By linear is meant that most of the data that was available was data where individuals or humans had been exposed at high dosages. As we're talking here about dosages in the neighborhood of 5 rad, and most of the data on humans was associated with dosages of 100 rad or more. So that in estimating the effects at 5 rads, we had to make the assumption that the effect that was observed at 100 rads was 20 times worse than the effect that was observed at 5 rads. So that's what's called the linear extrapolation of the data. This criticism, although it has been directed towards our approach by the Atomic Energy Commission, the linear relationship is the only relationship that has been accepted by the International Commission on Radiological Protection. They indicate in their reports that this is the only sensible public health approach to use towards the data. But more than that, Dr. Ella Stewart in England published an article where she was able to demonstrate the effects on humans at dosages of 1/3 of a rad. This means dosages right at the level of the existing guidelines. Her data says that the use of the linear extrapolation is not only a sound public health approach, that it is most likely scientifically valid. Now, her data were the result of diagnostic x-rays performed upon a pregnant woman. She shows that in the first 13 weeks of pregnancy, if a fetus is exposed to one x-ray film, and this is about 1/3 of an hour, that the subsequent childhood cancer and leukemia incidence will be doubled. So it's a very fantastic and a very measurable effect at a very low dosage and on humans. The data very strongly supports the fact that any amount of radiation, no matter how small, will be harmful to man. And that's really all the linear extrapolation of the data said in the first place.
Our experiments, as I understand it, show that children are much more vulnerable to radiation than adults.
Yes, this is true. The fetus in the very early stages of development is somewhere in the neighborhood of 100 to 200 times more sensitive than the adult. The newborn child and the young child are somewhere in the neighborhood of 10 times more sensitive than the adult. Now, our estimates of the cancer induction as a result of guideline exposure didn't take this particular factor into account. As a matter of fact, Dr. Linus Pauling estimates that exposure to guideline radiation level would result in an additional 96,000 additional cancer deaths each year. The major reason why his estimate differs from ours is that he is appropriately weighting the greater sensitivity of the developing fetus and the young child. We didn't do this because we felt our numbers were drastic enough as they were, and I guess in a way we were leaning over backwards not to inflate the issue any more than was absolutely necessary.
If the doctors Goffman and Tamplin felt that they had leaned over backward, Dr. Bond did not. He publicly characterized their findings as scare-laden and as gross exaggerations, in that they were based on the supposition that each and every person would be subjected to the full amount of allowable radiation each and every year, while other scientists answered this by asking why any individual, especially children and pregnant women, should be exposed to greater radiation risks as a result of peaceful, but as they pointed out, commercial use of the atom. As for the Goffman-Tamplin suggestion that the guidelines be cut by a factor of 10, Dr. Bond says,
I do not see the necessity for that recommendation. It's a matter of opinion. Man has always lived in a sea, if you will, of radiation. But man has evolved in an environment of radiation exposure. We do not know that there is a dose that is absolutely safe. On the other hand, there is no absolute proof that there may not be such a dose. So in establishing standards, one makes the conservative assumption that there is no dose of radiation that is absolutely safe, and one sets its standards accordingly. This is a proper conservative approach to standard setting. What this means roughly is that for any given situation, some relatively small population that might be exposed in that situation should not receive more than 170 milligrams per year from all sources covered by the standards. However, the actual exposure of the population would be, in any event, much less than that. You see, this would be the exposure for a small group. The average for a very large population would have to be much less than that. And in addition, I would like to say that the exposure now to the population from all sources covered by the standards is a very small fraction of this so-called maximum permissible dose, or the 170 milligrams per year. So the population is not now being exposed to anywhere near that value. As I say, it's a matter of opinion as to whether the standards should be reduced or not. I do not believe that it is necessary to reduce them. And in any event, I see no reason for haste in the matter, because the exposure of the population now is a very small percent of the standards that are now established. I know of no source of exposure that is liable to raise the level of exposure appreciably over the next decade or so. So that even if one disagrees with the present standards and feels that they should be lowered, I do not see any basis for introducing an element of urgency. In other words, the standards, if they are to be revised, and they're continuously revised, can be looked at in an orderly, thorough, objective fashion, and there's no basis for urgency.
But we've had surprises, unpleasant ones, in the past. DDT is only one that comes to mind. What if we are surprised by the atom, and it's too late?
I think that statement might better apply to other environmental factors than radiation. You see, radiation is different than other environmental pollutants in that it was very early recognized that there are potential hazards from radiation. And before the nuclear
industry, if I can call it that, achieved any significant size, a large amount of study was inaugurated on the effects of radiation, so that I think it is fair to say that we know more about the effects of radiation, although we have much more to learn, than we do of almost any other potentially hazardous factor in the environment. So that I do not see a firm basis for anyone making the statement that it may be too late. Of course, something completely unpredictable is always possible, but radiation has been studied very thoroughly, and it would be inconceivable to me that we could be very far out of line on our concepts of what radiation does.
Recently, a council chartered by Congress stated that it too saw no need to change the standard. But still, the controversy goes on. Professor Abramson of the University of Minnesota's School of Medicine says of Drs. Goffman and Tamplin,
many others agree with them. For example, Dr. Carl Morgan, who is the head of the Health Physics Department at the Oak Ridge National Laboratory, made estimates at a Senate hearing which were a little bit higher than Goffman and Tamplin's estimates, but within the uncertainty involved. The International Committee, the ICRP, will latest report come with numbers that are essentially the same as Goffman, Tamplin, and Morgan's numbers. The risk seems to be fairly high to the whole population, although the risk to each individual in the population is relatively low, but the numbers are not small. And the evidence is accumulating that there is, in fact, no threshold exposure for ionizing radiation. The results increase with increasing exposure and starting with zero exposure. I think that power reactors can certainly operate with essentially zero releases of ionizing radiation. We could still have them, but we will have them, and they can operate very cleanly. The same is not the case for plowshare. Plowshare is intrinsically dirty. You have an atomic explosion, it's essentially uncontained, and you're going to have radioactive material.
John Kelly is the director of the Division of Peaceful Nuclear Explosives in the AEC.
I think that for all the radioactivity that's low as possible, radiation is not an unknown phenomenon. Radiation occurs naturally around us, and both cosmic dangerous radiation and natural background radiation, and radioactivity in many of the minerals and rocks that we've lived with. And if we can keep the amount of radioactivity to which people are exposed for these kind of purposes small as compared to that which they get just by living. So maybe instead of getting just what you would get in the environment, but slightly more, but certainly not enough to cause any immediate effects. And you get some significant advantage in the end product, such as having a canal or a harbor that you could not have similarly. But you have to make this kind of risk-benefit analysis, and that's a part of the game.
Dr. Tamplin does not like the game.
Operation Plowshare is based upon the premise that we spend billions of dollars developing nuclear bombs, and they ought to be good for something. The Plowshare program is nothing more than an answer going around looking for a question. The need for the Plowshare program has never been established. As a matter of fact, Dr. Teller, who is the father of the hydrogen bomb and the father of the Plowshare program, has indicated that we haven't been funded enough to be able to find out whether this program is going to be of any benefit to us. So by the sheer process of blowing off these bombs, we're just indiscriminately spewing radioactivity about the landscape. And we're doing it when no real need has ever been demonstrated for the technology. It's a technology that happens to be available, and it's going around trying to find some market for itself.
If officials and scientists, both in and out of government, can't agree on how to peacefully use the atom and under what regulations, citizens, voters are going to, someplace along the line, have to render judgment. To find out more about the atom and man, you might wish to write to the Scientist's Institute for Public Information, 30 East 68th Street, New York, New York, zip code 10021. Or to the Atomic Industrial Forum, 475 Park Avenue South, New York City, 10016. More about this area of our ecology in our next report, Energy and Man. Produced by Group W, Westinghouse Broadcasting Company, with Dr. Harry Shapiro of the American Museum of Natural History as consultant. Can Man Survive is written and produced by Walter McGrath. Paul Callan is the executive producer. I'm Garry Moore.